Alright, so let's look into this bell work here where it's asking you to just factor the quadratics. So quadratics are equations with x squared, and when you have an x squared, you want to try to get factors or a set of parentheses that when multiplied gives you the third number, but also adds to give you the middle number. You might remember us doing this in the first semester. So let's think of numbers that multiply to give us 15, the third number or the constant here. So numbers that multiply to give you 15 are 5 and 3. That's what I can think of. And when I think about it, 5 and 3 could add to be a 2 if I make one of them a negative. So this is where I have to put my x's down because if I drop my x's, I can multiply them to get x squared. Here's a 5, here's a 3. Now, this is a negative 15, which means one of them is a negative. So I'm going to choose the 5 to be a negative and the 3 to be a positive. And this is just me guessing and checking. So negative 5 times positive 3 does give you negative 15. But when you add negative 5 with positive 3, you get negative 2. So this factor works. The other side is equal to 0. So now, once you have your factors, notice that the x squared is no longer the highest power. The highest power now is x to the first, which is much easier to solve. We're going to set each factor equal to 0 and then solve it out. So if I were to do this, x minus 5 equals 0, x plus 3 equals 0. I'll add 5 to both sides so I can get 5 by itself. So this first one here is going to be x equals 5. How about I write the answer here? So x equals 5 for the first one. And then this one, if I subtract 3, x equals negative 3. Or x equals, I'll write it nicer here. So it looks like x equals 5 and x equals negative 3. That's my final answer. So you're going to try to factor and then set them equal to 0. Solve for x, and we have 2x value, which makes sense because this is x squared, so you should have 2x values. This one here is x squared minus 9. This is a binomial, but it's a special type of binomial. This is what we call the difference of squares because there's a minus sign, and 9 is a perfect square, meaning if you took the square root of 9, it's a nice number, it's a whole number. The square root of 9 is 3, so that means that if I were to do like 3 times 3, I would get 9. So if I factor, I want to use a 3. I'm going to drop my x's because I need x to make an x squared. I'm going to make this one a negative 3 and this one a positive 3. It doesn't matter the order. But I need a negative 3 and one to be a negative 3 and the other to be a positive. So when I multiply, I get a negative 9. But when I add, they cancel. So that's why there's no middle term here. All right, so now that I factor, I'm going to set each factor equal to 0. And then solve for x. So this one I would be adding 3 over. So x equals positive 3. This one I would be subtracting 3 over, and x equals negative 3. And so this is my final solution. So x equals 3 and x equals positive 3. All right, so the reason why we are factoring for a bell work is because we're going to need that skill when we get into solving for logs. You'll see what I mean when we get in there. All right, so solving logs. One of the things I want to make very clear is that those properties that we were learning are helping us make the problem a little bit easier when we have logs. Notice how like these equations, you have multiple logs on one side. Well, it would be really nice if we could condense that to one log. Wait a minute, we've just learned how to condense, right? We learned the properties of logs, which I will write up here, but they're in our last journal. When you have a log and it's multiplying inside, you can expand it using addition. So if it's multiplication, you can expand using addition. When you have a division, condensed by division, you can expand using subtraction. And whenever you have a log base and the inside has an exponent on your variable on the inside has an exponent, then that exponent can come out and be on the front of your log. And so these are the 3 properties for logs, really important to have. Now, this first one here is log x plus log 4 equals 2. So what I'm going to do is try to combine these first. So that's the first thing to do. You want to combine them to make the solving easier. I also want to mention you want to check your answer because these are log problems. So logs are very finicky. Remember, logs don't like, so logs cannot have negative numbers or 0 inside the log. That's really important. So make sure you do check and make sure that this doesn't happen, that you get a negative or a 0 inside the log. So the log must have positive numbers inside. All right, let's start with the first one here. So this one has a plus sign, so that means that when I condense them, when I write this as one log, I have to multiply this 4 with this x. So this is going to be log 4x equals 2. Now I also noticed that this log doesn't have a base, so I'm going to write in a 10 because when there's no base, you assume it's 10. And notice the goal is to get x by itself. X is inside the log, so to get rid of it, I'm going to have to use a base of 10. So if I use a base of 10, this wipes out the whole log and the 10, but I have to base the 10 on the other side. So this becomes 4x equals 10 squared. So 10 to the second power, because 10 here is a base and 2 is now an exponent, 10 to the second power is 100. So if I were to solve for x, I might have to divide by 4. This cancels. X is equal to, well, 100 divided by 4 is 25. And this could be my answer, but let's double check here. If I were to plug 25 in for x, that would still be a positive number inside the log, so we're good. So as long as the number is a positive, you're fine if it's inside the log. So this is my final answer. 25 is a valid answer. All right, let's move on to the next one here. So this log here has a minus sign that is attaching them. So that means if I want to condense them, I have to use division. And so that way I can bring the inner parts together. So this is going to be log 3 divided by x, because this is a minus sign, so I have to use division. And this doesn't have a base either, so I'm going to assume it's 10 as well. And so from there, I want to use a base of 10 to cancel out with that log, because x is inside the parentheses, so I need to get inside of it, so I have to cancel out this log. That means I have to use the other side and use a base of 10 as well. So this 3x drops down, and this is 10 to the first power. 10 to the first power is just 10. Now I want to pause here and start thinking with you guys. Notice how there's an x in the denominator. We're not really used to seeing x being in the denominator, but this is perfectly fine. One way we can get rid of the denominator and try to get the x out of the denominator is to actually just think about where x is placed. So if x is in the denominator, that means you're dividing the 3 by x. To undo division, you must use multiplication. So what I'm going to do here is something that seems strange, but I'm going to multiply this side by x. Because if I do, that means that these two x's cancel. But here's the thing, x doesn't get rid of. Because anything you multiply to one side, you must multiply the other side by the same item. So I have to multiply the other side by x as well. 3 comes down, and now this is a 10x. So now I'm going to try to divide by 10 to get x by itself. Just our normal type of math here. And so now x is equal to 3 over 10. Or if you were to divide in your calculator, 3 divided by 10 is like 0.3, I think. Now, let's confirm that this here is the answer. So if I take 310, which is a positive number, and I plug it into this x here, it's still going to be a positive number. So this is valid. Here, it's still going to be a positive number whether you plug it in or not. All right, so now let's try out these ln problems. Last time we talked about ln's, we basically said that ln's and logs have the same properties. So you can use those log properties for ln's. When I look at this problem here, I notice that both of these ln's are attached with a plus sign, so that means I can multiply the insides together. So this is going to be ln 7 times x, because I multiply when it's in addition. And now I have the ln's together. So now when I look at this problem here, I need to figure out how do I get rid of ln? Because x is inside. I need to get to x, but in order to get to it, I have to get rid of ln to open it up. So to get rid of ln, we have to use, if you remember, e. E allows us to cancel out ln's because e and ln are inverses of each other. But if I e this side, I have to e the other side, which is perfect because then both ln's are rid of, and now you have a 7x equals 28. And now this is your basic algebra problem. I'm going to divide both sides by 28, or not 28, by 7. And so x cancels, and x is equal to 4. 28 divided by 7 is 4. Let's just double check to see if this answer is valid. If I plug a positive 4 in for x, this seems to be fine. It's still going to be a positive number. And so this is a valid answer. All right, so let's do one more slide before we get into the homework problems. I'll try to do 3 homework problems with you guys too. Okay, so in this example here, we have a log, and they're attached with a plus sign. So immediately I'm thinking, okay, well, I'm going to have to combine them using multiplication because this here is addition. So this is going to be log base 2. I'm going to multiply x times x minus 6, and the other side is 4. So if I multiply the inside here just to clean things up, I have to distribute this x. So this becomes log base 2, x squared minus 6x equals 4. So when I look at this here, I'm like, x is inside the parentheses. I have to get rid of log base 2, so I'm going to use a base of 2 to do it. And that gets rid of this log here, but I have to base 2 on this side. So this makes it x squared minus 6x, that drops down. 2 to the 4th power is like saying 2 times 2 times 2 times 2, 2 multiplying itself like 4 times, which gives you 16. So I've kind of brought everything down now, but one of the things I want to mention here is that what I notice about this problem is that you have an x squared. Anytime you have an x squared, you are dealing with a quadratic and you have to solve in a particular way. So that's why we had to learn how to relearn how to factor. So if you have a quadratic, I recommend you put it in standard form first. So standard form is when you have the x squared and the x to the 1st power and the constant, the trinomial, all in one side, and the other side equaling 0. This makes it a lot easier to factor. Because you're asking yourself, what 2 numbers multiply give you the constant and add to give you the coefficient in front of x to the 1st power. It just makes it a lot easier. So what I notice here is that this is not in standard form. Like x squared and x's are together, but not the constant. So what I'm going to do is bring the 16 over by subtracting 16 to both sides. This would cancel. So now I have x squared minus 6x minus 16. And now when I look at this problem, this is now in standard form because notice this here is a trinomial with the x squared, the x, and the constant, and this side 0. Now if I were to try to factor, I'm going to be thinking about what numbers multiply to give me negative 16, but add to give me negative 6. So think about it. I think 8 times 2 gives me 16, and I think they could add to give me 6 if I'm strategic about the signs here. So I'm going to drop down my x's, my 8, and my 2. I'm going to make the 8 a negative and the 2 a positive, and I'm going to just bring down the 0. Now, negative 8 times 2 does give me negative 16. Negative 8 added with positive 2 does give me negative 6. So these two factors do work. So now I'm going to set each factor equal to 0. And I'm going to solve. So I'm going to add 8 to both sides, so x equals 8. Subtract 2 on both sides, x is equal to negative 2. So looking at this here, these are the 2 answers, but remember, we do need to check. If I plug in a positive 8 into this equation, this would give me a positive 8, and this would be 8 minus 6, which is still a 2, a positive 2. So this 8 does work. If I plug in a negative 2 in for x here, that would be a negative number, right? And that's not good. Logs don't like negatives, so that negative 2 is not going to work. So x equals 8 is the only valid answer we have here. All right, so let's try this last one here. This one is two ln's and they're attached with a minus sign. So if they're attached with a minus sign, let's use division here to combine the like terms. I'm going to make a big fraction here. I'm going to take the 6 minus 2x and put that on top since it came first. And 3x minus 8 goes on the bottom because it came after the minus sign. Now, notice how the x's are all inside here. So to get to it, I need to get rid of the ln. So I have to use a base of e. So that wipes out. 6 minus 2x over 3x minus 8 equals e to the 0 power, which is 1. And then the bottom here has a x that's in a denominator. So I have a denominator here. So I want to think about, okay, well, if I have a denominator, let's try to get rid of it as treating it as one unit, right? Just like what I did with the x in the denominator in a previous problem, what I'm going to try to do is multiply it by the same factor so that I can get rid of it. Division will get rid of multiplication so they can cancel. But because I multiplied 3x minus 8 on this side, I have to multiply it on the other side as well. So I'm going to multiply this by 3x minus 8. So then the 6 minus 2x comes down. This is just multiplying by 1, so you're technically just multiplying 1, which is multiplying itself. Or you can distribute the 1, it really doesn't matter. So this is still 3x minus 8. And now I'm just going to solve this out by maybe adding the 2x to both sides. 6 minus 3x plus 2x is 5x minus 8. I'm going to add 8 to both sides. So this becomes a 5x. 6 plus 8 gives me 13. I think in this, oh, not 13. 14? Yeah, 14. And then if I divide by 5 here, 5's cancel. So x is equal to 14 over 5. Or, if I really think about it, 14 over 5 is about 2.8, right? I don't mind if you write your answer as a fraction or decimal. Either way is fine. But I want to see us in decimal so you can think about this number for a moment here. If you were to plug in 2.8 into this problem here, let's think about 6 minus 2 times 2.8. If you were to multiply that through and then subtract it from 6, you would get, I'm just doing the math right now, 2 times 2.8, subtract that from 6, you would get 0.4, which is fine because it's a positive number. So as long as it's a positive number, you're going to be okay. This one here, you're going to multiply by 2.8, just to double check here. If I multiply this out, subtract it with 8, I also get 0.4. And so this is valid as well. So this is definitely a valid answer because you get a positive number inside the log, which is fine. All right, so now I'm going to try out some homework problems here. This first one here, you're trying to, solve for x. So here I notice there are 3 logs. Be very careful. Do not cross out the logs right away. You want to do some condensing here. Notice how there are 2 logs here. So to combine these two, I need to take a look about how they're attached. They're attached with a minus sign. So that means I'm going to be dividing both of these terms here. So this is going to be log 4 x squared minus 4 over x plus 2 equals log base 4, 1. So once I notice that both sides have a log base 4, if I base 4 to both sides, they immediately will cancel on both sides. So I really just have an x squared and an x plus 2. And this side's just a 1. So when I look at this problem here, I'm thinking, okay, I got a denominator. Maybe I need to get rid of that by treating that as one unit. And so because this is a division, I can use multiplication. and multiply by x plus 2 so that I can cancel the denominator out. So then I have to multiply this side by x plus 2. And this will be just 1 distributing, so it's just itself, x plus 2. And this would be just x squared minus 4. I just dropped down the top part. And I think that's pretty much it on the multiplying by the denominator to both sides. Now this part here, notice how there is a quadratic, right? So there's a quadratic, that tells me, okay, I need to put it in standard form to make it easy to factor then solve. So to do this, my recommendation is, notice how x squared is positive on this side. I would not recommend moving x squared unless it was a negative x squared. The reason why is because it's easier to factor when x squared is a positive coefficient in front. So I'm going to move my x and my 2 to this side so I can keep my x squared a positive. So this would be subtracting x to both sides, subtracting 2 to both sides. This cancels, x is equal to 0, and now I have x squared that comes down, there's no like to combine it with, a minus x that comes down, and then negative 4 minus 2 is negative 6. So when I look at this problem, I can see now it's definitely in standard form, and now I want to try to factor. Like two numbers that multiply to give you 6, but could add to give you negative 1 are like 2 and 3. So if I were to factor, like 2, 3, I'll make the 3 a negative and the 2 a positive, because when I multiply, I get a negative 6, but when I add, I get a negative 1. So this works. And so now I'm going to set each factor equal to 0. So x equals 3. And x equals negative 2 as my answer here. But remember, I do need to check my answers to see if both of them are valid. So if I plug in a 3 squared is a 9. Like, I'll work this out kind of visually, but 3 squared minus 4 is like 9 minus 4, which is 5. 3 plus 2 is 5. So this is definitely a valid answer. If I were to plug in a negative 2 into this equation, a negative 2, I immediately notice this equation, negative 2 plus 2 gives me a 0. So this is not valid, because you can't have a 0 inside of log. That's not possible. It gives you something undefined. So x equals 3 is the only answer. This one here is very similar to one of the journal problems. These are both ln's and there's a minus sign. So you're going to bring them together using division. And then this side 0. So x's are inside, ln's are in the way, so I'm going to use an e here to get rid of ln, and e the other side as well. So 5 minus 3x over 4x minus 9 drops down. E to the 0 power is just 1. And then when I look at this, I have a denominator here, so I'm going to treat that as 1 unit, and I'm going to multiply it to both sides. And so I'm going to multiply it to this side, 4x minus 9. So that means that this here will cancel. Five minus 3x comes down, and then I'm going to distribute this one, but you know, multiplying anything by 1 is just itself. So this is 4x minus 9. And then I'm going to solve this out. So I might want to add 3x to both sides. That cancels. 5 equals 7x minus 9. So I'm going to add 9 to both sides. That cancels. 7x equals 5 plus 9 is 14. If I divide by 7, x is equal to 14 over 7, which is 2. And so when I look at this problem here, there's only one answer. Let's see if it's valid. So if I plug 2 into this equation, 5 minus 3 times 2, this becomes 5 minus 6, which is a negative 1. Oh no, we can't have negative numbers. So that means that this answer is invalid. So if all the answers are invalid, this is what we say: there is no solution. There's no solution here to make this log statement true. At least not in the real number. So let's do one more, and then we'll be done with this video. So this is number 7. And number 7, I want you to notice that both sides have a log, but there's not multiple logs. So the other problems, you have multiple logs where you have to condense them first and then try to cancel them out. Notice how just both sides already has them condensed. If you had to get to the x, you would use a base here to try to get rid of the log base 3. But then you would immediately have to do it to the other side. So I'm going to base the other side by 3. So they cancel. And now you really just have 3x plus 8 equals x squared plus 2. And then from there, I'm going to try to solve by subtracting 3x to the other side and subtracting 8 to the other side. I subtracted to this side here because x squared and the x's are all on one side. It just makes it a little bit easier to handle when you are starting to factor. So the left side 0, x squared plus, x, let me put a little 1 here. So this is 1x minus 3x, so that's going to give me, let me grab my eraser here. It's going to give me a negative 2x and a minus 8 that carries down. So I combine these two terms, negative 8 just comes down, and if I factor, then maybe 4 times 2 might work. So 4 and 2, if I make the 4 a negative and the 2 a positive, I think this works out. Negative 4 times positive 2 makes a negative 8. Negative 2 times a positive 2 makes a negative 2. Oh, sorry, a negative 4, I said that wrong. Negative 4 plus a positive 2 makes a negative 4. So this works. So they multiply to give you negative 8, they add to give you negative 2. So now we're just going to set each factor equal to 0 and solve this out. So I'm going to add 4 to both sides, that cancels. Subtract 2 to both sides, that cancels. X equals positive 4, x equals negative 2. And before we call this the final answer, let's just double check. If I plug 4 back into this equation, this should be fine, right? Plugging a positive number and multiplying and adding it by a positive number is fine. It's going to keep it positive. So will this one. 4 squared gives you 16. Add another 4. That gives you another positive number. If I have a negative 2, I'm not sure if this will work. So let's double check here. So 3 times negative 2 plus 8 gives you negative 6 plus 8, which is a positive 2. So the first log works. The second log, you have a negative 2 and you're squaring it. Add a negative 2. So this makes a positive 4 minus 2, which is a positive 2. So it looks like this does work for these two solutions are both valid. And that's it. I hope this helps you guys out with the homework. Until next time, guys. Bye.